I bet you are struggling with this type of expression under differentiation, calculus. And we say the derivative of exponential functions. Exponential are those values that you see them, they're having e to the power of something, stuff like that. So how do we find the derivatives of such expressions? So follow me as I take you through the sample of it. The first question says find the derivative of each of the following. The first one is exponent 2x. So the first thing you want to do is to say that let y, the first question is exponent 2x. So I will say let y be equals to e raised to power 2x, so that I'm going to say that put u to be 2x. So anywhere I see u, I will represent it with 2x, and the expression will be y is equals to exponent u, simply because u has been replaced with 2x. Then you move further by differentiating them one after the other. So the first differentiation will be for u with respect to x, that is the u all over the x. The differentiation of 2x will give you 2, and also differentiate y with respect to u, that is the y all over the u, the y du. Differentiation of exponents e raised to power something, maybe u or x, will give you the same as the derivative. So differentiation of e raised to power u will still give you e raised to power u. Nothing is changing. So you need to bring this together by using the chain rule, which is the y all over the x is equals to the y all over the u multiplied by the u all over the x. And what is your dy all over the u? So you have it to be that dy all over the u, which is e raised to power u, times the u all over the x, which is 2. So when you multiply this together, the expression will be 2e raised to power u. But you are close to the final bus stop. So you said that recall, or but you said it earlier that u is equals to 2x. So replace your u with 2x, and the y all over the x will be equals to, so let me continue it here, so that the y all over the x will be equals to 2 exponent 2 exponent u, and your u is what? 2x. So 2 exponent 2x, and that is the final answer for that expression. So the next second one on the list is the one which says find the exponent of negative 3x minus 1. So what I want to do is I will follow the same procedure, the same way I've solved this one also. So step one is to say that what? Let y be equals to exponent 3x minus 1. Then the next thing is to say put u to be negative 3x minus 1, so that the y will now be equals to exponent u. Then you find the u all over the x. By differentiating this, you will have negative 3, and also the y all over the u. Differentiation of this will still give you e raised by u, so that your dy all over the x, which is the y all over the u from chain rule, times the u all over the x. Then you will have it to be that this is the y all over the u, which is e raised to power u, multiplied by negative 3, which is the u dx, and that is negative 3 exponent u, but your u is what? Negative 3x minus 1. So final answer, the y all over the x will be equals to negative 3 exponent negative 3x minus 1. So that is simply the solution to that. The next one on the list is exponent tan x. So I want to bring that into play also. So I would say we say that let y, step one, let y be equals to tan x, so that let y be equals to, sorry, let y be equals to exponent tan x, so that I will say put u to be equals to tan x, and the expression will be y is equals to e raised to power u. So the same step, the u all over the x, differentiation of u with respect to s, differentiation of tan s will give us sec square x, and also the u, the y all over the u, differentiation of e raised to power u will give you e raised to power u as the derivative. So remember from chain rule, the y over the x is equals to the y all over the u multiplied by the u all over the x, and that is simply the y all over the u is e raised to power u times the u all over the s, which is sec square s. So when I bring this together, this will simply give me sec square x e raised to power u, sec square s e raised to power u, or which is the same thing as saying I can bring anyone first. So I can also arrange it as let's say e raised to power u coming first, times what? Sec square s. But recall that but u is equals to what? Tan x. So anywhere I see u, I will put it to be tan x, so that my dy over the x will be equals to e raised to power tan x multiplied by sec square s, and that is the derivative of this. So the next one is d, which is find the derivative of exponent sine 4x. So I want to take that as well. So step one, as usual, step one will be that let y be equals to exponent sine 4x, and I will put u to be what? Sine 4x, so that y will be equals to e raised by u, then the u over the x, expression of this u with respect to x, differentiation of sine 4x will give you 4, then sine s will give you cos a, that is cos 4x, and that's the derivative of that. So the y all over the u will still give you e raised to power u. And recall from chain rule that the y all over the x is equals to the y all over the u multiplied by the u all over the x. And that is simply the y all over the u, it is e raised to power u multiplied by the u all over the x, which is 4 cos 4x. So when I bring this together, I will have this to be, I can multiply this one as 4 e raised to power u times cos 4x. But recall that u is equals to sine 4x. So my dy all over dx is equals to 4 e raised to power sine 4x, which is u, times what? Cos 4x. And that is the derivative of this. So thank you for watching the video today. See you in the next video. Please follow my channel, my page, subscribe to the channel, and like my video and share. Thank you. See you in the next video.